Hello everyone, thank you for checking out this video. You are with Coach Jordan from Territory Academy. Right now we are going to be solving this question together. For this lesson, instead of completing the square, which is not so feasible since these expressions don't look like they can be factorized, instead we are going to be making use of a certain substitution so that we can deal with this compound quadratic surd form over here. So let's take a look. So seeing that the square root of 2x minus 5 is common in both of these surds, you can let's say y be equals to the square root of 2x minus 5 over here, right? And therefore, before we move on to substitute this into the original expression, we first want to see whether we can express x in terms of y. So by squaring both sides, we'll have y squared equals to 2x minus 5. Alright, and to make x the subject of the formula, 2x will be equals to y squared plus 5. Hence, x will be y squared plus 5 over 2. Alright, so now that we can express the root of 2x minus 5 into y, and x in terms of y, we are now ready to make these substitutions into the question. Alright, so therefore, our original expression now becomes the square root of, remember instead of x, we are now writing y squared plus 5 over 2 plus 2 plus 3 times of just y. Remember, both of these can now be replaced with y simply just like that. So in my right hand surd, I would have y squared plus 5 over 2 again, minus 2 plus y. So let us now look within each of these surds respectively to see what can be done. So over here, if I make them all the same denominator, I would have y squared plus 6y. Right, 2 times 2 will give us 4. 4 plus 5 will give us 9 over 2. And for the one on my right, I'll do the same thing. Y squared plus y times 2 to give us 2y. Minus 2 times 2 gives us minus 4. 5 minus 4 gives us plus 1 over 2 as well. Now at this stage, we notice that my denominators for both of my expressions within the surd is the same as the value of 2. Hence, we can actually factorize out the 2, but make sure that you include the square root with it as well. Otherwise, the value will be completely different. So we can now insert the brackets. So right now I have y squared plus 6y plus 9 minus the root of y squared plus 2y plus 1. So conveniently enough, you can now see that both of these are actually now of the forms of a plus b whole thing squared. Hence, the square root of this will then be equals to y plus 3. And the square root of this, using our identity again, would be y plus 1. Right? And then now we can slowly work this out. Y plus 3 minus y plus 1 will simply give us a value of 2. And you can see that 2 divided by root 2 would simply give root 2 itself. And therefore, we have achieved a very nice looking answer over here. So just to recap, every time you encounter a compound quadratic surd where the expressions within the surd don't look like they can be easily factorized, as long as you see more than one occurrence of the same expression, a substitution may be in due order. So in this case, we chose y to substitute the root of 2x minus 5, and then we had to find a way to express x in terms of y as well, such that my entire expression only contains y and constant values. Alright? And therefore, once we reach up to this stage, notice that this y squared plus 6y plus 9 is of the form y plus 3 squared. And y squared plus 2y plus 1 should be easily observed to be the square of y plus 1. And hence, we obtain a nice answer of square root of 2. We have completed this lesson. Thank you for watching this video, and I hope you have enjoyed today's lesson. Goodbye and see you again in another lesson.
If you would like to learn more from these tutorials, please smash that like and subscribe button.